To test the normality of the data. How to test the normality of the data using Kolmogorov-Smirnov test on SPSS. So before moving to the test, first I show you some of the data layouts that are possible to analyze the data. This is some of uh, the alpha toxin samples here. See, so these are 8 different yields. This type of the data layout is called the stacking. All the samples are stacked under the variable toxin, and here we have another variable yield that is indicating that these 16 values are related to the yield number 1 and the next 16 are related to the yield number 2, and similarly to so on. We have 8 different type of the yields, each contains 16 values. And then we have another type of the layout here. See, this is a data file which is available in the SPSS library. That file is behavior. So you can see here different type of the behaviors are lying in every column. So this is one, talk, kiss, write, eat, etc., etc. So this is unstacking form of the data where different variables are lying in the different columns. So this is unstacked form, and in this, which is the aflatoxin file, these are the stacking form of the variable. So in both type of the data layouts, we will apply the Kolmogorov-Smirnov test to test the normality. So first I use the file which is behavior. So to apply the normality test, which is Kolmogorov-Smirnov test, we just follow the path. So first we click on analyze and then non-parametric tests, and then we have legacy dialogues, and in the legacy dialogues we have one sample case. So while clicking this, so you can select the variables for which you want to test the normality. For example, I'm selecting write, eats, sleep, mumble, read. So as you select the variables here, and by default the normal is already checked, whereas we can test the distribution fit on the uniform distribution, exponential, and the Poisson as well. But by default it selects the normal distribution. And now just click the OK button to see the output. You see here, this is the output of the Kolmogorov-Smirnov test. And here in the last row, you can have the p-values, the significance values to have this test. So the right p-value of the Kolmogorov-Smirnov test is 0.650. For the eat is 0.361. For the sleep is 0.803. For mumble 0.596, and for the read it is 0.477. So all of these p-values are greater than 0.05, which is our level of significance. So you can say that all these 5 variables that I have chosen to test the normality, they follow normal distribution. And now let's move to the second file, which is aflatoxin. So here it is. So to test the normality, the procedure is almost same, that you just go to the analyze, then non-parametric tests, and then legacy dialogues, one sample case, and you select the variable where your study variable is lying with toxin. So the toxin is selected here, and the normal is here. Just pressing the OK button and review the output. You see here, we have in total 128 observations, and this entire column has a p-value 0.549, which is again greater than 0.05. So the toxin variable following a normal distribution. But here one of the problem is, see here, this is not only one variable under the toxin, though it's a one variable only, but it has 8 samples. You see here 1, 2, 3, 4, 5, 6, 7, 8. And if you wish to test whether each of these samples or the yield follow normal distribution, so here you need to apply the split file command so that we can have a separate p-values for the each yield type. Now how to apply the split file? We use the data here, and in the third last option we have split file. So while you click the split file, Here you will use the second option, which is compare groups. And now we will select the variable that contain the information which is differentiating the yield types from each other. So once you select the variable on the basis of which you want to split the main file, you just select this variable and pressing the OK button. Once you click on the OK button, then a message would appear on your output screen that sort cases by yield, split file layered by yield. This is a clear indication that a computer system has split this main file into the number of categories as per the variable selected in the split file. So as we have 8 different categories, so in this way we have 8 different type of the data sets which are virtually the system has uh, created. And now we will follow the same procedure to test the normality. So click on the analyze and then non-parametric test and legacy and then one sample case test. So you just select the aflatoxin which is already selected here, and then you just click OK button. You see here we have separate p-values, and these are different p-values for 8 types of the yields. If you see the p-value of the yield number 1, that is 0.780, which is greater than 0.05. So you can say yield number 1 is from a normal population. The yield number 2 is also from a normal population. So the p-value is 0.246, greater than 0.05. And similarly, you can check any of the yield. So yield number 4, its p-value is 0.709. It's also greater than 0.05. So we can say it's a normal distribution or a normal uh, distribution, normally distributed yield type. So the yield number 6 similarly, as the p-value is 0.868, so it's greater than 0.05. So we can say the yield number 8 is also following, yield number 6 is following normal distribution, and similarly up to so forth. We have yield number 8, its p-value is 0.667, so it also follows normal distributions. So from the analysis we conclude that all of the given 8 yields follow normal distribution and none of the yield type is non-normally distributed. So that's how you can apply the normality test. And now let me share another file with you, and that is exam anxiety. Here how many variables we have in the files. So if you just click on the variable view, we have one of the variables code, the other is revise, then exam anxiety, and the gender. So what is the detail under these variables? The code, the participant code. Here it's only the codes of the participants. You can assume these are just roll numbers. Such we have the roll numbers of the candidates, so it contains. And now the last variable is gender. Gender means whosoever is the candidate, that would be indicating the gender is a male or the female. You can see here we have categories. One is a male and this 2 is a female. So here we have 3 more variables, which is revise. The revise variable is the time spent on revising the exam. That variable is exam performance in percentage, and anxiety, that is exam anxiety. So this is the detail something uh, clarifying the variables, that what the variables are and what is lying under these variables. And now if you click on the data view, you can see all the observations. So how many values we have here, you can see here how many total values we have. So 103. So 103 candidates data are lying under this data sheet. So if you click this button here, that would be translating the code to the respective gender. For example, the 1 was related to the male and 2 is for the female. So where the 1 would be in the variable, so 1 would be indicating the male. So here we have male, females, and codes. These are, you can say, the roll number, as I said earlier. So if you apply the normality test here, you shouldn't consider the normality to test the gender, because gender is a categorical variable and a nominal categorical, which is just uh, having the 2 categories, male and a female. So you don't need to apply the normality test. And here we have the codes. The codes are nothing to do with, these are just for the understanding and traceability of the candidates. These are the roll numbers, and we'll never apply the uh, normality test here. So if you wish to test the normality, you can test the normality of the revise exam anxiety. But before testing the anxiety, you have to off the split command that you have applied earlier for the aflatoxin data sheet. And the question is how to off the split file command. So for the same, you will apply the data and you will go back to the split file where you apply this, and then we have first we analyze all the cases not split and then you press OK. So that's how you can off split if you have already applied this command. So to check the normality of the revise and examine anxiety variables, we follow the procedure. Just we press the analyze first and then non-parametric and legacy, and then we have one sample case test here. So uh, select all these variables here. So in the normal conditions, they are here in this portion, but this is the place where you select the variables for which you want to test the normality. And now I have selected all these three variables. So just press the OK button, and you see here the normality test result is in front of us. And the time spent in revising the p-value is 0.003, which is far less than 0.05. So we can say that time spent in revising data, this is not normally distributed. This is non-normal. And the exam performance is 0.048. That is very close to 0.05. So we can say approximately the exam performance is normally distributed. It's rounded. If this value is rounded to two decimal places, we can have the 0.05 value. And otherwise, I have seen this variable. It contains many outliers, and if we uh, get rid of all these extreme values and the outliers, this would be better. P-value it would be greater than 0.05. So I am assuming that the exam performance variable is a normally distributed variable. And now the anxiety, it had p-value 0.016, which is less than 0.05. So you can say that this is non-normal as well. So here we have tested three variables in which only one is approximately normal, whereas the two time spent revising and the exam anxiety, these are non-normally distributed. And now what we can do more from this data sheet, you can see here we have tested the normality of these three variables that is combined for the gender for the male and female combinedly. But if you wish to test whether what is the situation with the male's data and the female's data separately, so obviously here we need to apply some of the command which could separate the data of the male and female, and that is the split file command. And now we apply the split file. So split file is here. You just click on split file and now select the variable which is differentiating the gender. So the gender is a variable that is actually categorizing two of the male and female. So once you select this variable under the option of the compare groups, now don't forget to press the OK button. So as you press the OK button, you will find here in the output window that split file layered by the gender. So it is the proof that our splitting has been done. And now we move to the normality test. So analyze and then normal, non-parametric test and legacy dialogues and one sample case test. You select all these three variables and pressing the OK button. So here we have separate results for the male and the female. So under the time spending, you see the male's p-value is 0.016, which is non-normal, and same is the case for the female. It's also less than 0.05, which is 0.102. So you can say that the male's data and the female's data for the time spending both are non-normal. And if you see the exam performance of the male, so its p-value is 0.293. It is far greater than 0.05. So you can say that the male's data follow normal distribution. And separately for the female, it's 0.341, which is greater than 0.05. It's also follow normal distribution. And the exam anxiety, the p-value for the male is 0.327, which is greater than 0.05. It follows normal distribution, and whereas for the female it's 0.047, which is a little less than 0.05. So you can say that the data for the female under the variable exam anxiety is non-normally distributed. So that's how you can apply the normality test. The normality test is very important. It has great significance because in many of the significance tests, such as t-tests and f-tests, ANOVA, etc. This is very mandatory that your variables should follow the normal distribution. And moreover, in the regression analysis and other statistical methods, normality assumption is very mandatory. So that is basically the significance of the normality test, and how to test the normality I have explained earlier.